your next chemistry lesson with me, we are drawing electron dot and structural formulas. Making sure my mic was on. Okay, so this is how you do this. So you take the electron dot notation. So your first example on here is chlorine 2. So Cl2. So you take Cl and you give the electron dot notation for chlorine, which is boom, 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 5. How many electrons are in chlorine? 7. 6 and 7. So that is the electron configuration for chlorine, but since it's Cl2, we need 14 valence electrons, because 2 times 7 is 14. I can barely fit that. So we need 14 valence electrons for this to be Cl2. So we're going to give us another one. 1, 2, 3, 4, 5, 6, and 7. Okay, so to join these together for the electron dot, we are going to, first of all, erase this. So see how I'll draw it off to the side so we can have a little model of it right here of the configuration of chlorine. 4, 5, 6, and 7, like that. So when you're doing this, literally all you do is, here's Cl, and you're going to have the 2 up here. The 1 you're going to put on, hold on. This is 1 and 5, 2, 3, 4, 5, and then 6, except, and then 7's down here. Except you'll put, you'll still have 6, and there's no 8. So, whoops. Here it is, and then you're going to have the other one. And there's going to be 1, 2, 3. See, okay, this is where we share an electron. Is the 4th one right here. Since there's no 8, the 4 right here is where these will share. Right here. So this right here is the shared electron. Okay. That's 4, and then 5, 6, and 7. So these two, like this one, is the shared electron. So yes, that's the electron that gives them both 7. So 1, 2, 3, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, and 7. My numbers are terrible. So that's the electron dot notation for chlorine. Okay. Now we're going to do the structural. Okay, this is the structural formula. So we're going to take our chlorine, both of them, like normal, and we're going to do the normal notation. 1, 2, 3, 4, 5, 6, and 7. And then same on the side. 1, 2. This is not in order. I'm just copying from the other one. Okay. So now, and so for where the shared electron is, it's literally just a line. So I guess like there. So for that one shared electron, there's a line. So then this gives, that counts as the electron, and that gives the 7. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Easy. Okay? That is how you do that for chlorine. This one's a little bit harder, this next one. This is H2S. Okay? This is 2 hydrogen, 1 sulfur. So we need 2 hydrogens. We'll just write down what we got. Hydrogen, hydrogen, and sulfur. Okay? Now we write the electron configuration, the dot configuration for both of these. 1. And then sulfur has 6. So 1, 2, 3, 4, 5, 6. Now, this is what we have. Just keep this in mind. And now we're going to share these. So to do that, you got to keep sulfur with having 6. So to share that, all you have to do is rewrite it like this. Sulfur. So it's going to have 6. 1, 2, 3, 4, 5, and 6. But now you're going to share these electrons with the hydrogen. This is the shared electron with sulfur and hydrogen, because that gives hydrogen 1 electron and it gives sulfur the 6 that it needs. So these both have 1, and then sulfur has 1, 2, 3, 4, 5, 6. That's how you do the electron dot. Ignore my handwriting, it's terrible. Okay. Now for the structural, you will do the same thing, sulfur, and do 1, 2, 3, 4, 5, 6. And then you have your hydrogen down here. Just structural is just the same, except instead of dots, there's lines. So this gives hydrogen the 1, and it gives sulfur 1, 2, 3, 4, 5, 6. See? That's how you do the structural one of sulfur. It's HS2. Very easy. Okay, and then we'll go on to the last one. Last one on here is BRI. That's bromine iodine. I don't really know what that would be called. I can't think of it off the top of my head. But take bromine and iodine. Bromine has 7, so 7, 1, 2, 3, 4, 5, 6, and 7. And iodine also has 7. Just going to copy off of here. This is not in order. Okay. So now you just got to share the electrons over. So for the dot configuration, this is going to be like this. To where it's going to give them both 7. Okay. And I. So you're going to share the electron. So we have bromine that has 7 and iodine that has 7. So 1, 2, this is where they're going to share at. 3, 4, 5, 6, 7. And then iodine, 1, 2, 3, 4 right there, 5, 6, and 7 right there. See, they share this electron right here, and that gives them both 7. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, and 7. So they both have 7, and that is the electron dot notation for bromine and iodine, whatever that compound may be. Okay, phosphorus, and then 3 fluorides. Those are too close together. Okay, phosphorus has 5 dots. So phosphorus right here. And then, so you're going to go ahead and put the dot notation on phosphorus. So 1, 2, 3, 4, 5, 6, and 7. So you're going to put 1 down here, a fluorine. And since fluorine has 7, they're going to, okay, here's the 1. They're going to share this 1 right here. So then they have 2, 3, 4, 5, 6, and 7. You're going to put another 1 right over here. Okay? And it's going to have 1. 2 is where they're going to share right here. 3, 4, 5, 6, 7. You'll put 1 more right over here. 1, 2, 3. They're going to share the 4 right here. 5, 6, and 7. Just like this. And then, see, share here, and share here. So that is the dot notation of whatever element PF3 is. There you go. The structural notation for this one will look like this. So you have bromine with 1, 2 is where they'll share, 3, 4, 5, 6 down here, and 7. And then iodine with the same amount, 1, 2, 3, 4, 5, 4 is where it'll share. 6, 7. So since they'll share right here, here's the line, and that still gives them all 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's the structural notation for the bromine iodine. Okay, now for the structural notation of the phosphorus 3. Okay, phosphorus needs 5 electrons. So 1, 2, 3, 4, and 5. So all these fluorine ones, I'm going to line them up down here. They need 7. 1, 2, 3, 4, 5, 6, 7. And I'm just gonna line it up off of here so I don't have to write it, so I don't have to keep counting it out. And then, okay, so this is how they will share, I think. Yes. These will share here. This one will share here. And this one will share here. Because that should give them all what they need. This will give phosphorus 1, 2, 3, 4, and 5. This will give the fluorine 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep. That is how you do that. That is the structural notation for the phosphorus fluorine or fluoride. I don't really know what that would be. Next one is CO2, carbon dioxide. So we have carbon and then 2 oxygens. So carbon needs 4 valence electrons. 1, 2, 3, 4. And oxygen needs 6. 1, 2, 3, 4, 5, 6. And then the same one for here. 1, 2, 3, 4, 5, 6. Just like that. That is your dot notation for CO2. And now we will do the electron dot, how you would bond them together. Okay. So this is the electron dot notation for CO2. So you have your oxygen, your carbon, and another oxygen. So oxygen is going to have 6. 1, 2, 3, 4, 5, 6. Carbon is going to have 4. 1, 2, 3, 4. Oxygen is going to have 6 again. 1, 2, 3, 4, 5, 6. Okay. There's going to be double bonds on these. So they're just going to be, be here, here, and then here, and here. So to write that a little bit neater, they'd be like this. Here, and then you have these 2. You have those 2 on that side. C, and then O. Whoops. The other double bonds here, here, O, and then you have the 1, 2, 3, and 4 down here. You have all those are bonded. Then you have 1, 2, 3, 4. So these right here are your double bonds. And that'll come in handy for the next, the structural one. So, for the structural one, you have O, C, and O. So your oxygen is going to have 6 again. 1, 2, 3, 4, 5, and 6. 4, 1, 2, 3, 4, and 6 again. 1, 2, 3, 4, 5, and 6. So this is the same thing, just with the double bonds. So just going to be lines. Here, 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 and here. Since all of the atoms, not the atoms, since all the electrons on carbon have been shared, it doesn't have any. And since there are 2 being shared with carbon from oxygen, it's only going to have 4. So, go. 1, 2, 3, 4, and 1, 2, 3, 4. And that is how you would write the structural configuration for carbon. The next element is hydrogen, carbon, and nitrogen, HCN. So we got hydrogen right here, carbon, and nitrogen. Okay, and we just put the dots on to see. Got my periodic table here. We got hydrogen with 1. Okay, carbon has 4. 1, 2, 3, 4. And nitrogen has 5. 1, 2, 3, 4, 5. Okay, so now that we have this, have all of the things here, and now we have to do the electron dot notation. Okay, so now we gotta do the bonding. We have nitrogen, carbon, and hydrogen. We're gonna flip them around. Hydrogen. Okay. So we have nitrogen has 5, so it's 1, 2, 3, 4, and 5. Carbon has 4, 1, 2, 3, and 4. And hydrogen just has the 1 right here. Okay? So now we bond them. So we're going to share this one with hydrogen. So this is the bond between carbon and hydrogen right here. So we don't need this one up here because that's the one they share. Okay? And then we bond nitrogen and carbon 3 ways. Here. Whoop, I need my red pen. Here, here, and here. So the 3 bonds, that is the dot configuration for this one. Okay? And now we can do the other one, the structure one. Okay, just put the dots back. I'm going to use a bolder font to see if that helps us see a little bit better. Nitrogen has 1, 2, 3, 4, 5. Carbon has 1, 2, 3, 4. And hydrogen has just 1 up here. So, to bond them, line, can leave, there's the bond. We have 3 bonds. Go here, here, here. So it's going to be just like that. The lines don't have to be black or anything. We can see, just like that. Because, and then since they'll already be bonded in all of these spots, the only dots left are the 2 on the side right there. So there is your structural configuration for HCN. Okay. The next one is NH3. Nitrogen has 5 electrons, so it's going to be 5 valence electrons, that is. 2, 3, 4, 5. No, that's not where 5 goes. 5 goes up here. Okay. And then 3 hydrogens. So it's just going to be 1, 1, and 1. So that's what we got to work with. Okay. Now, configuration is going to look like this. The N, have the H here, an H here, and an H here. So we'll do the normal dots. So 1 for hydrogen, and then we're going to have 1, 2, 3, 4, 5 for nitrogen. So for the bonds, they're just going to be bonded here, here, and here. So we don't need this, that. And then everybody has what they need. 1, 1, 1. And then for nitrogen, 1, 2, 3, 4, 5. So that is how you would bond the hydrogen, hydrogen 3. I don't really know what that would be. And for the structural configuration, there is going to be the same similar thing. We're going to put the H's down here a little bit more. Okay. So do the normal 1, 2, 3. Whoops. Like that. And then 1, 2, 3, 4, 5 for here. Okay. Now, all we have to do is bond them. So they'll bond here, here, here. And that's it. So we don't need these little dots, because everybody has what they need. So the next one is silicon and then 4 of bromine. So silicon is Si, and then we have bromine, 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 and bromine. Silicon has 4 valence electrons, so it's 1, 2, 3, 4. And then this is the I to the dot. To the dot to the I. And then the bromine has 7, so it's going to be 1, 2, 3, 4, 5, 6, and 7. And the same for all of these. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I can't mark all the way down there. It's supposed to have 7. I think you get it. The way you would write this is silicon in the middle. You're going to have bromine, 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 and bromine. So I just write them out like normal. Silicon only has 4, so 1, 2, 3, 4. Bromine, this is the dot to the I. Bromine has 7, so it's me 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I can't mark all the way down there. That's the 7th one right here. Okay? And then there's 1, 2, 3, 4, 5, 6, and 7. Now we just got to bond them. So since silicon only has 4 and there are 4 bromines, all we just have to do is bond one here, 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 and here. Now silicon shouldn't have any more dots anywhere besides these 4. And then they should all have 7, if I am correct. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, one of these is from the silicone. So this is 1, 2. I think you get, oh, it's so confusing. I'm so sorry. I hope you understand that. It's hard to see sometimes. I promise it makes sense. It's like, okay, here's the 1, 2, 3, 4, 5, 6, 7 for bromine, and erase this one too. And here is the 7 for the other bromine. 1, 2, 3, 4, 5, 6, 7. Ignore this blue dot, that was a mistake. And then down here as well. Okay, and now we don't have enough dots. I erased one that I shouldn't have. So I erased one that I shouldn't have erased. That was an accident. Oh my gosh. 2, 3, 4, 5, 6, 7. Yep. Here's a 7. 2, 3, 4, 5, 6, 7. So there is the 7 for all of them. And the, wait, bromine needs 7, right? Yes. And then the 4, change colors, 4, 2, 3, 4 for silicon. And there you go. We're going to do it a similar way. Silicon, bromine, 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 and bromine. I'm going to rise this up a little bit because we can't write super close to the other stuff at the bottom. Okay, so this is what we can go ahead and do to make it a little bit easier. We know it's going to bond here, 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 and here. So this is all going to, so that makes our silicon bonding done. We just have to put the remaining electrons for the bromine. Since we're already bonded here, that's 1, 2, 3, 4, 5, 6, and 7. 3 should be right here. 1, 2, 3, 4, 5, 6, 7. So this is one. This is another number. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. That was confusing, sorry. Yeah, I did that in the wrong, I did the last one in the wrong order, but it is still 7. So we have the 1, 2, 3, 4 for silicon, and then 1, 2, 3, 4, 5, 6, and 7 for bromine. So it's going to be bonded just like that. And that is how you do that. So the electron or whatever combining, that is how you do it.